Here we go. Okay. So here is an example with the playing cards. So let's assume we have a standard deck of 52 playing cards. Okay. Now we're going to choose a card at random. Okay. Let's say we do that. What's the probability of choosing a king? Well, so for this event, how many ways can this event happen? How many outcomes are there corresponding to choosing a king? Well, we know there are 4 kings, right? There are 4 suits, and each suit has a king. There are 4 kings. So the probability of choosing a king, okay, is 4 out of 52. I mean, here the sample space would be all the cards. You know, you would list them all. I know that's a lot, so we don't have to. But what's nice is we don't have to do that. So that's the probability of choosing a king. Again, there are 4 kings in the deck. So there's 4 ways that event can occur. There's 52 possible outcomes altogether. Because you could choose any one of the 52 cards. Now, for choosing a club, what would that probability be? Well, there's 13 cards that are clubs, right? There's 13 of them in that suit. So there's 13 ways that event can occur. Because of that, the probability would be 13 out of 52. I mean, only choosing one card. So it's 13 out of 52. So that's what we get there. Okay, now, here's a question I want to ask you guys. From that deck of cards, what's the probability of drawing a -1? I want, you can either type in the chat or just say it, I guess. Maybe type in the chat is better. But what would the probability be of drawing a -1, do you think? Anyone? Right? You want to draw a card that's a -1. Well, that's one. Well, is there? That's a good question. Someone asked, there's a -1 in the cards. Well, 2 people said 0. 0 meaning it can happen. Well, yeah, that's right. Is there a -1 in that deck of cards? You can't draw a negative number. Thank you. There is no card in there that's labeled -1, right? Because of that, it's impossible. We can't draw. There's no way that event can happen. Hence, there are no outcomes associated with it. So there is no card labeled -1. So the probability should be 0. And that's what's going to happen. And that's what happens, actually. An event is said to be impossible if it has a probability of -1. I see -1. If it has a probability of 0, sorry. So it has a probability of 0. Then we say the event is impossible. On the other side of it, though, if the probability is 1, then we say the event is a certain event, meaning it's going to happen. It's going to happen. Pretty much guaranteed to happen, in other words. And also this I probably should have said earlier, although I thought I did, but I wrote it here. We denote the events by capital letters. Again, I don't know if you guys know set theory, but those events really are sets, which you could think of as collections or groups of something. And the probability of an event is this. That's what happens here. There's something else I wanted to say. Oh, that's right. If you went back to like these, let's say, right? You notice how these fractions are not in lowest terms? I think the book writes the fractions in lowest terms, and actually you don't want to do that here. If I were to reduce this to lowest terms, it would be 1 over 4, but then the interpretation might be off. So, I mean, if you do happen to, without thinking, write it in lowest terms on a quiz or test, I'm not going to take points off. But you don't want to write it in lowest terms. What you actually also could do, you don't have to do this either, though, is you can actually write this as a decimal and convert it to a percent. If you leave it as a fraction like this, that's fine. Probably saying a lot, so let's keep going on. Let's keep moving. All right, so I wanted you guys originally to try this, but for some silly reason, I put the answers on the same slide, so let's just do it together. So again, let's suppose we're rolling that same 12-sided die from before. We're rolling that same 12-sided die from before. So what's the probability of rolling a 3? Well, if we went back to the sample space, there's only one way you can roll a 3, right? Rolling a 3. There's only one way that can happen. So that probability would be 1 out of 12. Same thing with 5. I mean, really, it's a fair 12, although I didn't write that, but we can assume it is. So I guess we're assuming it is that every one of the outcomes are equally likely. So rolling a 5 is just as likely as rolling a 3. Hence, you get 1 out of 12 as well. And there's no number on there's no -3 on that die, right? It's impossible. Because of that, the probability of rolling a -3 is 0. And also, the probability of rolling an even number, right? How many ways can that happen? Well, if we let me go back to the sample space. I should have put it on that slide, but I guess it's okay. We have 2, 4, 6, 8, 10, 12. There are 6 numbers here that are even. So there are 6 outcomes corresponding to the event of rolling an even number. There are 6 outcomes. So the probability then would be 6 over 12. Again, probability is the number of ways that event can occur. Number of outcomes associated with that event, and you're dividing by the total number of outcomes. Okay, are there any questions? I can't see the chat, so if you have a question, use that, what do you call it, the hand raise feature. Or speak into your mic. Okay. Now here's another one. This one's a little bit different, as you can see. Here, right, we're rolling a standard 6-sided die. What we want to know, though, is what's the probability of not rolling a 2? Not rolling a 2, not rolling a 2. Okay, so how can that event occur? Well, to not roll a 2, as I wrote here, means you have to roll something besides 2, correct? You have to roll something besides 2. So you can roll a 1, a 3, a 4, 5, or 6. Any one of those 5 outcomes. So there are 5 outcomes associated with not rolling a 2. There are 6 outcomes altogether, right? There are 6 outcomes in the sample space, so it's 5 out of 6. 5 out of 6. Okay? Again, there are 5 ways the event of not rolling a 2 can occur. And there are 6 outcomes altogether. Now, I think we saw already, it's also here, the probability of rolling a 2 is 1 out of 6. There's only one way you can roll a 2, namely just roll a 2. But notice if I add these together, as I'm doing here, I'm getting 1. So if I add the probability of an event with the probability of that event not occurring, so if I add the probability an event occurs with the probability the event does not occur, in this case, rolling a 2, I'm going to get 1. Well, that's no coincidence. In fact, we have the following result here. We have this notion of an event and the complement of its event. The complement of the event is the event does not occur. So the complement of the event occurs if the event itself does not occur. That doesn't make sense. Let me try again. If you have an event E, okay, its complement will occur if E does not occur. The notation's a little weird. They have a bar over it. Yeah, I did my best to write it out using, PowerPoint. But basically what we saw in the previous slide is this. If you take an event E, take its probability, and add the probability of its complement, you get 1. So an event E plus the probability, so the probability of an event E plus its complement, the probability of its complement gives you 1. Let me just, before I go more into that, let me just stop it.